Jai Hind. Hello cadets. So from the physics syllabus of the NDA written exam, today we are going to cover an article about pumps. Okay. Now wherever we want to lift or make the flow of make the liquid flow, we use a pump. Now based on how the liquid moves around the pump, the direction of the flow of liquid at inlet and exit, and the overall arrangement that is used to increase the pressure and velocity of the liquid, the pumps are of two broad or fundamental types. They are classified as axial flow and centrifugal pumps. In axial flow pumps, the pump is mounted or installed right into the path of flow of the liquid somewhere here in this plane, that is, and the blades of this pump, they are very much in the shape of the blades of an exhaust fan, and the pump can rotate about this axis in this direction. As the pump rotates, the bent blades of the pump, they push the liquid forward, and as a result of that, it starts the flow of liquid. So as long as the blades are rotating about the axis of rotation, they keep on pushing the liquid in forward direction, and as a result of that, it produces a kind of a continuous motion of the liquid along the axis of rotation. And because the inlet and exit of the liquid both are along the axis of rotation of the pump, therefore it is called as an axial flow pump. The axial flow pumps are typically used in places where you don't have to amount for greater pressure or greater velocity of the flow. So in common applications where you don't want the liquid velocity to be very high, or you have a problem of location, not enough space is available for the installation of the pump, that is why you are forced to use the pump right in the path of the liquid. In those situations, we always prefer an axial flow pump. The blades are tilted at certain angle so that as it rotates, it also pushes the liquid forward. And as a result of that, what happens is the liquid flows with greater velocity and greater pressure. The biggest disadvantage of axial flow pumps is that they cannot impart larger velocity, or they cannot produce larger pressure of liquid in the pipeline. That is why wherever we want to deliver large volumes of liquid, we always prefer centrifugal pumps. In case of a centrifugal pump, the entrance and exit of the pump is little bit different. First, the centrifugal pump have a disc called as an impeller. An impeller is like a circular disc with a large hole at the center, and this is the inner and outer circle. Between the inner and outer circle, there are what do we call vanes. Vanes are the projected metal portions which accelerate the liquid in radially outward direction. So if you look at it from the side, the impeller is like a metal disc with a hole in the center like this, and the vanes look like this in the side view. The liquid enters from the central hole in this direction. As the vanes and the impeller, everything rotates like this, and liquid enters here. Because of the centrifugal force exerted by the rotational motion of the impeller, the liquid is forced away from the axis of rotation. So if you see in this view, the liquid is coming in here that is axially, and it is getting pushed away radially, and as it is getting pushed away radially, the reason behind this push is the centrifugal force exerted by the impeller on the liquid. Now everything, the entire impeller and the inlet exit, they are enclosed inside the casing, inside the pump casing like this. Imagine that this impeller is revolving in this direction. Now if it is revolving in this direction, then there is an exit on this side, okay, on this side of the pump. So whatever the liquid that has been pushed, all of that liquid finally and ultimately will flow through this exit, and from here it will enter the pipeline. Sometimes this kind of impeller design is usually there for low power application. Like if you have a pump of half horsepower or 1 horsepower, then it typically might have vanes which are like a straight line. But if you have a pump of greater horsepower, like imagine you have a pump of 5 horsepower, 7.5 horsepower, or even 10 horsepower, in that case the vanes are never straight. On the other hand, the vanes are curved. So these curved vanes produce a greater centrifugal force, plus it improves the discharge rate, the volume flow rate of the liquid. But always remember that if this kind of vane design is there, the direction of rotation of this impeller will be like this, so that the liquid will flow along the vanes away from the center under the action of the centrifugal force. Again, it will be enclosed in a casing, and from here the exit will be in this direction. So the entry of liquid in the pump is along the axis of rotation. So we say axial entry and radial exit. This is completely axial flow. Entry and exit both go on in axial direction along the axis of rotation of the blades and the impeller assembly, while here it enters along the axis and it leaves along the radius. Finally, all of the liquid is collected together and it comes out from a single pipe. The biggest advantage of this pump is that it can handle greater volumes of water. It can provide that huge amount of water with greater velocity and greater pressure. When you consider a centrifugal pump, the first drawback is called the priming operation of the pump. Okay, whenever you want to do priming of the pump, imagine that you have installed this pump by the well. So it is by the well, the water level is much below, and from water there is a pipe coming into the pump, that is the inlet, and then there is an exit or outlet. As long as the inlet pipe, the pipe from the pump till the water level, as long as that pipe is completely filled with water, only and only then the pump will give you continuous delivery of water through the outlet. But if there is no water in the inlet pipe, then the pump will not give you any water at all, no matter for how much time you keep it switched on. So what you have to do now is you have to prime the pump, meaning you have to manually fill water in the pump casing, and also you have to make the inlet pipe completely filled with water. Once it is completely filled with water and then you start the pump, in that case, now you get continuous discharge of water from the outlet. Now, the centrifugal pump comes in two designs. One is called as the monoblock and the other is called as the submersible. In monoblock pump, electrical motor driving the pump and the impeller assembly both are fused together. They are never separate, but they sit on the top of the well. That means the electrical winding and the exterior body of the pump never comes in contact with water. The water comes in and moves out only through the impeller casing. In submersible pump, it is also a kind of a monoblock pump where the entire pump is submerged below the surface of water. The motor winding is insulated. So in monoblock pump, motor winding is of open copper wire, which is insulated by a very thin insulation called laminate. But in open well submersible or bore well submersible pump, there are impeller wheels, no doubt. There is a motor also, but the winding of the motor is covered with a thick insulation. So that winding as well as the pump, both are submerged in water, but because the wire is very well insulated, the current does not leak out of the winding. Now the biggest advantage the submersible pump is offering is, first, you never have to prime the pump. It is already submerged, so always there is going to be water in and around the impeller casing as well as the motor winding. So you never have to prime the pump. Second advantage, the overheating of the motor, electrical motor, is completely eliminated because the submersible pump is always submerged in water. Third advantage is because it is installed at the bottom, the vertical height through which it has to pump water is comparatively lower. Along with that, because it is completely surrounded with water, the inlet can have any diameter. So the inlet water pressure is comparatively much higher. So outlet water pressure is even higher. So for the same power requirement, if you compare a monoblock and a submersible pump give you 1.5 times to twice more water discharge, more water pressure. That is why for irrigation purpose today most of the places have a submersible pump compared to a monoblock pump. For household appliances, household applications, small power applications, we normally use a monoblock pump, but for large discharge applications we usually prefer a submersible pump. Okay, that is all. Thank you very much.